we knocked it around, and I had just done a presentation of this sort exactly. And so they thought, well, uh, let's have Julian give this talk. So yeah. So yeah, your sandcastle icebreaker question was timely because we're going to be having a sandcastle building contest on the Oregon coast this weekend at Cannon Beach. So um, that'll be a big event there. So also I have to mind my behavior and what I say because the president of the ISCS is actually on this meeting too. So I invited her. So anyway, I'm going to go ahead and share my screen and get started with the presentation. And yes, if you are interested, if you are a sand collector, and I'll have some resources at the bottom at the end of my talk. And uh, we would like to connect, and we like to trade sand, and that's how we build collections. And I'll get into all of that when we get into the sand collecting part of my talk. So we're going to talk about the science, beauty, and utility of of sand, but we're going to start with the utility first. Sort of why is sand important? I'm a geologist, and people who know me know that I am a hardcore mineral collector, mineralogist, and so I study minerals. And they are curious why I want to study sand. Well, it's just tiny minerals, and I like working with microscopes and looking at things under the microscope. So it was a natural transition to start collecting sand. So uh, the way we're going to cover our topics tonight is first talk about the utility of sand, how it's used in our civilization, how much sand is used, and then a surprising thing, paradox, that we have a sand crisis that's going on. And then we'll get into some science, not hard science, just a light treatment of what sand is, the components of sand, and a little bit of science of sand just to make it interesting. And then what I call the beauty of sand, sand collecting and the study and enjoyment of sand. So uh, in any talk I give, I'm going to recommend lots of books. I like to collect and read natural history books and nonfiction. So this book, The World in a Grain, is a great book about how sand is used in our society. And it jumps right into the sand crisis that we're having, and how there are people who are trespassing in national parks, not in the United States, but in other countries, collecting sand, and people who turn them in are being kidnapped, murdered, threatened. It's really a pretty crazy thing to think about because sand is one of the most abundant natural resources on the surface of the earth. Sand is part of, rock and sand are something that together are called aggregate, and they're the most used natural resources. And it is literally the foundation of society. And surprisingly, we're running out of sand. And we'll talk about how that happens. So how much sand are we using? We are using phenomenal amounts of sand. And 38,000 tons of aggregate per mile for one lane of typical interstate here in the US or anywhere, I guess. That's a lot of aggregate, a lot of sand and rock. And I don't know what an average building is, but the site where I got this information said that 15,000 tons of aggregate are used for the average size building. Maybe that's like an office building or warehouse type building or something like that, but that's a great deal. And even in the average house, we use a lot of natural materials, 400 tons. The foundation of your house, the slab that's poured, the foundation, and then sand is also used in a lot of things in making glass. You want windows to be able to see out of your house. The the gypsum that goes into the drywall, on the walls, everywhere. It's just all around you, in added to paint as fillers and pigments, and on and on. I show this photo from the International Space Station of O'Hare International Airport, and all of that white that you see there is concrete, and that uses sand and rock for that concrete, and it's very thick to hold up the weight of planes. Um, and think about how many airports there are in the United States. Think about how many there are worldwide. Then think about how many buildings and cities. So sand is one of the most widely used resources in the world. Trying to get your head around some of these numbers, uh, one other amazing statistic is that worldwide we're using 50 billion tons of sand every year. And uh, so, how do we comprehend that number? Well, first of all, the average cement mixer holds 9 yards, which is approximately 9 cubic yards. And that's about 9 tons. That really doesn't help us. We could figure out how many um, cement mixers that is. But I picked one of the largest states in the United States, California. If you've ever been to California, if you've driven the length of California, you drive for 2 days on Interstate 5 and you're still in California. And so, California, if you were to cover the state of California with 50 billion tons of sand, the amount of sand that's used in 1 year worldwide, it would cover the entire state 1.25 inches. And um, after 4 years, you've got about 5 inches, and it adds up, and it's just an amazing amount of sand that's being used. So um, some of the non-commercial uses, I guess, not industrial uses. Um, we like beaches. People like to live on the beach, and uh, they also like to visit the beach on their vacations and have summer homes or permanent homes on the beach. And cities will build buildings right up to the beach, and they cut down the vegetation, which is a natural barrier to erosion, and so they destroy the natural systems that protect the land and the beach, and so the beaches start to erode, and that's part of a natural process. And so to to build those beaches back up, the Corps of Engineers or some engineering firm has to step in and rebuild an artificial beach. And the way they do that is they'll have a dredge offshore, they'll pump sand onto the beach, and then it's spread around. And that has to actually happen every so many years. The beach has to be replenished, or what these are called, they're called beach nourishment programs. So the beaches are starved for sediment, and they erode and have to be replenished. So most of the beaches on in Florida, all most of the way around the entire peninsula of Florida are artificially supported through this beach nourishment programs like this, and in many other places in the world. And then you have things like this where people want to create new land out in the water, and they dredge sand up and build these artificial communities um, out into the sea. And this Palm Island, Dubai, this is one of, I think, three of these communities. And it's, of course, dredging up a lot of sand out of the sea there, and affecting ecosystems there, and creating these and using a lot of sand. Closer to home, for me, I live in Hillsboro, Oregon, and my house is actually in this photo. It's about just a little bit down from the horizon there. This plant is one of Intel's plants, and it's in Hillsboro, believe it or not. They have many plants, one in Sacramento and Phoenix and, of course, in the Silicon Valley. But they manufacture chips, and this is a 2 million square foot building where they slice up chips and photo etch them to make computer chips. And those are used in phones, in computers, and all kinds of technology. And it takes an ultra pure form of silica in quartz. And hold on to that fact because it has to be a very pure form of silica to be used to manufacture these chips. You can't have any weird trace elements in that, or you interfere with the microprocessor operation. And connected to the computer chip industry um, is a support industry. This is Spruce Pine, North Carolina, and this is the Uniman mine and plant there. And they have a very pure source of silica in the rock there. And so that quartz is mined, processed, and they actually make the crucibles that they melt the silicon down in before they grow the silicon boules that get sliced up and made into chips. So, okay. And actually, it's kind of a mystery where the pure, very pure sand comes from that's used to make computer chips. Anyway, I mentioned this specifically because over the winter, there was Hurricane Helene came in and destroyed the road between Spruce Pine and Asheville, and that was the way that the silica was taken. That was part of the supply chain route from Spruce Pine to Asheville, and so that was disrupted, and it's shows how tenuous our supply chain for some of these resources are, as well as the rarity of the pure silicon. And of course, the petroleum industry uses a lot of silica of special type for fracking, and this is in a mine in Minnesota, and it's a very pure but round uh, particles of silica that are quartz that are mined there, and that helps. It's injected into wells. They fracture the the ground and then pump this sand and water um, into the fractures, and the sand holds the fractures open and allows them to extract even more oil out of the mine. So these are just a number of uses. I mean, we could go into glass, bottles, all kinds of other things. So, okay, so what's the problem? Sand is everywhere, right? It's the most common resource in the world. So, you picture sand and you picture a desert, the dunes in the Sahara or the Namib Desert or all over Australia and the Western United States. It's very abundant, right? Well, true, but if you look at that sand up close, that sand is rounded. Um, the tan color is due to staining by iron oxide, and there are other things. And the sand, if you look at it microscopically even closer, you'll find that the sand has inclusions, and those impurities do not are not good for many uses. If you're making concrete, for instance, out of this sand, the sand is round, it's like ball bearings. And if you build a building out of that and put any kind of structure of any kind of height and weight on top of that, the concrete is going to fail. You need angular, clean, angular sand. So you don't just need any sand, it has to be the right type of sand. So this is how we get into the sand crisis, where we have actually a limited amount of the right kind of sand, and we're using it at astronomical rates as we continue to grow in civilization. So anyway, all right, let's get into what sand is. I think we all have some idea of what sand is. We picture some tan, sandy, warm beach somewhere, or maybe they're in the coast where you are. You have the quartz-rich sands there, and so you can picture that. We want to get into a little more detail and see about how many different types of sands we can talk about. And of course, I just mentioned desert sands like this. we picture the warm tropical beaches like this, and then we also picture dune sands like this in the Sahara or Namib. Geologists have a very boring definition of sand. It's any naturally occurring granular material that is of a size between 2 millimeters and 1/16 of an inch. So that's the geologist definition. The collectors of sand will sometimes stretch that and collect anything that's a natural thing that they find on a beach or in a river or glacial deposits or whatever. And so it's really fascinating. The more and more you learn about sand, the more things there are to collect. So we won't spend much time on some of this science, but just a reminder of where sand comes from. Anytime a mountain is formed, you have a continental collision and mountains are thrust up in above the sea. Then they're exposed to the elements, weathering and erosion. So you have freeze thaw cycles. You have rain, ice, glaciers are all attacking. Those are physical things that are breaking rocks down. Plants, tree roots will grow into cracks. Lichen secrete acidic compounds that break down the minerals in the rock. And so, however it is formed, you get a loose material broken out of that original source rock. Um, Rains will wash it into rivers and streams and wash it downstream, downhill by gravity, eventually depositing it into seas, oceans, and lakes. We also have uh, wind can blow some of that sand into sand dunes in desert environments. If you have an arid climate. We have places where in warmer climates you have coral, and coral gets broken down and washes up on shore onto the beach. You have seashells that are deposited on beaches as well. So these are all different ways that we get sand in natural environments. So starting from the mountain range and going to the sea, um, in left to right in this image, we have closer to the source, you have the particles have just been broken down. So they're angular, they're sharp angular fragments. Their grain size is very widely distributed. So you have large, medium, small particles of sand, and then you also have what geologists call textural maturity. That means it really talks about how many different minerals are in that sand, minerals and rocks. And again, close to the source, you have all these different things that have been liberated from the source rock. Many of those are robust and can take the travel, the journey from the mountains to the sea and just be broken down. But some of them weather physically and even chemically and get broken down into clays and things like that that are not um, do not survive the entire journey. So as you go from the mountains on the left, you have these angular, very poorly sorted and very complex mineralogically sands. They get more and more rounded. The grain size gets smaller and smaller, and it becomes closer to one grain size. And you get fewer and fewer minerals as you get to the area where the sand is deposited. So these are all the things that sedimentologists in particular will study in looking at sand, and they can put together the history of where that sand came from. So let's actually look at some sand then. Enough of this talking about the science. Let's look at it. So the way that we most people will use a hand lens, a handheld magnifier, to look at sand, and then a more comfortable, more efficient, effective way to look at sand is to use a stereo microscope or dissecting microscope. These are the things that are most commonly used in sand by geologists and in many laboratories. And these microscopes have anywhere from 10 to 40 or 50 times magnification, and that's plenty for you to look at sand. So this is a nice garnet sand from a place called Ruby Beach in Washington, here in the Northwest where I am. But if you want to get a closer look, you get a compound microscope, and this is the type that geologists use, which has a rotating stage and polarizing filters. And we'll be looking at some photographs taken with this type of microscope. But that allows a geologist to identify the components and do a little bit more with those components. So how do you make a microscope slide of sand? It's rock that's been broken down. We put sand in a mold. We pour epoxy over it. When it cures, we treat it like a rock. We glue it to a slide, slice it off. So the second image from the right there shows a specialized machine. You put the slide on that silver block and then feed it into the diamond saw, and it slices your chip off very close to the glass slide. And then you use the last machine, the one on the right, and you grind it with that cup grinder, grind it down until it's thin enough to see through with the microscope. And so then we go to that microscope. So here's a tray full of slides that have been made in that way. So I just wanted to show you the process, because that question does come up. How do you make a microscope slide of a rock or sand? So, okay. And then this kludge is how I photograph sand through the stereo microscope. Stereo microscopes don't have a fine focus, and so I cannibalized another compound microscope and use that for the fine movements to take photographs. And I'll take stacks of photographs and combine those into a very sharp image. Looking at the classification of sand, this is my only word slide, so we'll just go through this quickly. We have natural components and artificial components. The natural components are biologically derived. We call them biogenic, and they can be either fossil or modern components. Terrigenous components are those things derived from the weathering of rocks. They can be rock fragments, and rocks are made up of minerals. So if the rock breaks down completely into its component minerals, then we can have a sand composed of minerals. Another category is authigenic. Authigenic means it was formed in place. So think of dry lake beds. And dry lake beds, the sand is actually formed in place through evaporation. And there are other I have a good example of one of these authigenic sands here in just a few minutes. Astrogenic, I love including this one. It's anything derived from extraterrestrial material. They're extremely rare. Microtectites and micrometeorites. Finding and collecting micrometeorites has actually gained popularity in just the last few years. And there are a few good resources out there to tell you how to do that. Haven't gotten into that myself yet, but anyway, I'm just including it for completeness. And then artificial sands are things that are man-made or anthropogenic. Those can include glass, plastic, metal, slag. Slag is waste product from manufacturing and smelting and things like that, and there are many others. So, all right, let's look at some sands. Okay, biogenic sands. These are very common, and these are sands that are composed of modern seashells. That big white thing in the center on the left is part of a barnacle, and those are very common in places where you have rocky substrate or rocks on the coast. You'll have below the tide line, you'll have barnacles. And then, of course, the seashells and gastropods or snails. And then the other components here are rocks. Um, this is biogenic sand here from the Oregon coast near Coos Bay. And you'll see um, the things with ridges on it in the lower left, those are shell fragments, so like clam and oyster shells. The dark bluish purple grain on the right there is purple mussel, and there are several of those in this slide and more barnacle pieces. On the right, I found a large piece of coralline algae. And it's beautiful. They're very delicate. And I took this sample in my hand from the beach to my car, and it didn't even make it that far. They're very fragile and they break down, and they will become components of biogenic sands. And we're going to look at this is a great sample from Tunnels Beach, Kauai, one of the islands in Hawaii. And there are several biogenic components in this sand. So we'll look at this seashell fragment first, the one in the red circle. And this is a microscope slide or thin section. And you see we caught one of the seashells in cross section. And these are made of calcium carbonate, either calcite or aragonite. And the image on the left is normal bright field illumination. On the right is polarized light. And calcium carbonate is highly birefringent. And so you see that in the very bright, beautiful rainbow of colors in the image on the right. You can also see a change in the structure as the shell grew from those vertical lines at the bottom of the shell to that crystalline structure on the outside of the shell at the top. And then we have a gastropod or snail relative here, and we caught one in this section and sliced it. We were able to slice right through the middle of that shell, and you can see all the chambers of the whorls of the seashell, and in polarized light on the left. And then this is a beautiful thing, this bluish grain here on the left. That is a foraminifera. It's a type of plankton, and it looks beautiful in white light, but it also looks spectacular in polarized light. Again, it's made of calcium carbonate as well. There are other plankton that are made of silica, but I haven't managed to see any of those in a thin section yet. And this is a sea urchin spine. Sea urchins have these spines that surround their shell, and they will break off when the organism dies, and they'll roll around in the surf. And this is one that was found in one of our thin sections. And this is a very famous sand. You know, when you start collecting, this is one that you need to get in your collection. It's a star sand from Okinawa. And so these are tiny foraminifera. So these are the shells or test of an organism. And the organism itself lives inside the shell, and there are pores in there that allow it to feed and get nutrients. And very beautiful, very tiny organisms. It's a beautiful sand. And then we've been through modern components, but you can also have areas where there are fossil-bearing strata in that are being eroded out, and they're contributing uh, all kinds of sand grains, rock grains, but also fossils to the sand. And these are very interesting to examine. This one is from a creek in South Georgia, and there are bits of dinosaurs that have been found in South Georgia, lots of marine reptiles. That's the more common thing. And what we see here, obviously the large tooth from crocodile or something like that. There is also a ray plate in the left, just left center. And then in the center at the top, there's a black grain with an oval in it, an ellipse in it, in the that's grain. That's fish vertebra. And then you'll also see a lot of other white material in here that is broken bits of seashell, probably oysters. These are Cretaceous sand. So all of these are more than 66 million years old, Cretaceous age sand. So wonderful to study those. So leaving the biological world and going into the inorganic world, we look at terrigenous sands, sands derived from mountains and rocks, rocky areas. So this is a typical sand that you'll see. The white, gray, colorless grains are quartz and feldspar, and then the tan could either be some seashells that have been really broken down, or more likely another type of feldspar. So that's a very common sand that you'll see. And I want you to notice as we go through these, I live 90 miles from the Oregon coast, and I am absolutely, every time I go to the coast, I'm amazed at the diversity of sand that we find on the Oregon coast. So as we go through, note how many different types of sand I say are from Oregon. So we've already seen one, a biogenic sand. This one is not. This is another desert sand from Morocco. And I contrast that with the one from Oregon because this sand has a couple of things that just improving your observational skills here. Notice a couple of things about this sand. All the grains are about the same size. They're all very rounded and very, pretty, not completely well rounded. They're not complete spheres, but they have very few angular fragments. And so this is a common feature of sands that are transported by wind. Wind is a very good sorting agent, and it will sort out the sand so that you have all of the same size sands. And one last thing I want to point out is these sands have coatings on them, which give them a natural color. They'll give you a tan or red color to the sand in the sand dunes. And then this is the same sand. It's made up almost entirely of quartz, and this is in polarized light and has beautiful birefringent colors in polarized light. That's not my family, but it's a friend of mine, a geologist friend of mine, visited the famous green sand beach on the Big Island of Hawaii, and there's a volcanic cone there that spewed out a lot of olivine. And so the olivine is an iron magnesium silicate, and it is green. And this is what the sand looks like under a stereo microscope. And all that green, those are all olivine grains. So, and looking at them even closer in a thin section, they're also very colorful in polarized light. So white light on the left and polarized light on the right. Okay, and so this is a different green sand. This is again from Oregon. There's a shipwreck. The ship Peter Iredale uh, was stranded on this beach in 1912, and they've left it there, and it's just been disintegrating ever since. And I found a layer of this greenish sand on the beach and looked at some of the components. And One of the components that I found, this is instatite. Instatite is a pyroxene group mineral, and it has a nice, well-formed crystal. And this is derived from a volcanic source rock. And of course, if you know anything about the west coast of the United States, we have a lot of volcanic rocks. The Columbia River brings the sediment derived from those volcanic rocks down to the ocean. Longshore drift smears it up and down the coast, spreads it up and down the coast. And this is just one of the volcanic components of found in this beach sand. And we find this things like this, pyroxene minerals, amphiboles, feldspars, things that are found in commonly in volcanic rocks. And we'll see some others later. And this is another Oregon sand, but this could have come from in the world. It's a sand that is rich in garnets. All those pink and red and orange grains, all of them are garnet. And these are beautiful red sands. And um, there on the East Coast, where you are in Maryland, and from there north, you will find many beaches that have garnet sand on them. And go inland also, in the streams and rivers, you'll find garnet sands. Um, there are places in the Adirondacks which have a lot of garnets in the bedrock, and those erode out and are washed out to sea. So and concentrated in the beach. Garnet is very robust, and it will survive just about everything. I mean, they mine garnet sand and use it as an abrasive for sandblasting, another use of sands, and also use it for glue it to paper and use it for sandpaper. Uh, and this is uh, this is a sand from Emerald Creek. I still do not know why it's named Emerald Creek, but they find a lot of garnets there. And these garnets are very spectacular. They have very nice crystal form. They're very angular. Those angles are actually the crystal faces. And if you look at closer at the crystal faces, you'll see that they have these etch pits in them that reflect the internal crystal structure of the garnet. And then, so the image on the left is reflected light, just looking at the surface texture. But if you put light behind it, you can see inclusions inside the garnet. So as this garnet was forming, they're formed mostly in metamorphic environments. They trap fluids or other minerals in the area at the time they grow. And so those are become very interesting part of looking at garnet sands. Another Oregon sand, this one from almost in California, a place called Whales Head Beach. And this sand is, you can see a couple of orange garnets there, some green rock, which is serpentinite, which is the source rock for most of this beach sand. But the black is magnetite. And uh, magnetite, I'm used, as a geologist, I'm used to seeing magnetite in sands, but when I parked in the parking lot and walked out onto this beach, the entire beach was black. It was just solid black sand, almost entirely magnetite. There is also a little chromite in this. They have mined chromium from some of these beach sands in the past, and also ilmenite, which is a titanium mineral, and they get another mineral. This is not from Oregon. This is from Alaska, but they actually find gold on the beaches here in Oregon in many places. In fact, one of the cities on the Oregon coast is called Gold Beach. All right. And the last components of sand, well, no, the last terrigenous sand components that we want to talk about are rock fragments. This is from the famous black sand beach on the Big Island of Hawaii. And all of these black fragments are all basalt, which is the most common rock type on the Hawaiian Islands. And this is from Vik, Iceland. on the southeast corner of Iceland. And this is also all basalt. And both Hawaii and Iceland are sitting over hot spots, which erupt a lot of volcanic rocks that are composed just about entirely of basalt. So, of course, you're going to get black sands derived from these black basalt fragments. And then I was looking at one of the Oregon sands and I found this. This is a sand-sized grain. It's less than 2 millimeters, fits the scientific definition for sand, but it's an agate. And I'm a scientist, but I froze when I saw this. It's like there's no other word for this other than adorable. It's just this is a complete agate grain, shows the growth from the outside on the top in the lower right, growing into the center, and then it stopped growing the banded agate and started growing crystalline quartz. And so we find a lot of agate on the coast of Oregon. Rockhounds like to do beach combing, and we'll find pebbles of agate on the coast. But you also find them at all size ranges. Okay, we're moving into a new category of sands. This is oolitic sand. This is an authigenic sand, and this means that it was grown in place. And the way that these form is you have a briny water in which these grow, and there is the surf will wash grains of sand back and forth, and there is some grain, tiny grain, and this mineral, uh, aragonite or calcite, will start to grow on that grain. But as it's washed around, sloshed around in the surf, it will begin to grow on the grain and grow out in all dimensions and equally. So you get a sand that has all the sand grains are the same size and they're very well rounded. And if we slice them open and look at them, we can see what the core of the oolite is. And in this case, the core is quartz. So there were quartz sand grains, they're angular, and the calcium carbonate began to grow on that and grew out in all directions and formed this beautiful sand. I posted a picture of this on social media, and somebody asked me a very obvious question. Many calcium carbonate minerals fluoresce. So they said, does this fluoresce? And I'm like, oh, well, I guess I'll check. So I thought, this is an easy scientific question. You shine an ultraviolet light on it, and it either fluoresces or it doesn't. So this is the answer I got. So on the left, you see just reflected light and white light, and then you see ultraviolet light on the right, and you see one grain that fluoresces orange, and the rest do not. So this is a puzzle, and I don't know what to make of this. You need chemical analysis to start to figure out why one grain would fluoresce and another would not in this situation. More questions. Anytime you ask a question in science, you get an answer back, and the answer usually comes with 5 more questions. But it's a very fascinating sand, and this sand came from Antelope Island, which is in Salt Lake City, in the Great Salt Lake. Another famous authigenic sand is the white sands of of New Mexico, and this is all gypsum. And so that's not snow. This is all gypsum. That's mineral, the mineral gypsum, calcium sulfate. Made a thin section of it, looked at it, and not terribly exciting. But anyway, so that's what it looks like. And lastly, let's look at the last category of component, anthropogenic, man-made components of sand, plastic. This is also found on the Oregon coast, and this sand was formed when the story of this sand begins in March of 2011 when there was a very large earthquake struck the coast of Japan. And there was a tsunami that washed inshore, and many people were killed. It was a very deadly event, both the earthquake and the subsequent tsunami. But a lot of debris was washed out to sea, got caught up in the Pacific Gyre, and it ended up on the west coast of the United States. And the field of view here is about 4 inches across. So these are large pieces of plastic that floated across and accumulate on the Oregon coast in certain places. There are several beaches that on around the world that accumulate glass, and this is the glass beach on Kauai in Hawaii. There's a glass beach near Fort Bragg in California, and they're actually beautiful. They get tumbled frosted glass, and it's actually a beautiful sand. Now, this sand, you saw it before. This is another one from the Oregon coast, and I said it was a biogenic sand. Well, it is, but if you look closely, you'll see a brown glass fragment there. So, if you look at the sands under a microscope for long enough, you can find many different components in one sand sample. So, okay. Okay, those are all the components. Let's conclude with the last part of the talk is talking about the hobby of sand collecting, which is a lot of fun. It goes in so many different directions. So here's my sad dad joke. Sand collecting is a vile hobby. So when we collect sands, we see, many collectors, they'll collect in, different collectors will collect in all sorts of different things. Generally start out with either a film canister, if you have any of those laying around still, or spice jars and so on, and pill bottles and all kinds of jars. But collectors will put them into nice same-sized bottles, label them, and so on. So let's talk about collecting. Uh, there's nothing magical about collecting a sand sample. You have some kind of container, a plastic bag, or um, bottle, or some container, and a shovel or a spoon, and you put the material in the bag. Um, and take some notes. You can look at it with a hand lens and label the bag with a Sharpie or put a label in there. Um, Collecting the sand, uh, and I recommend that you label the bag first and then collect the sample. If you've ever wrapped a package and then tried to put the postage, the address on the outside of a package that you've wrapped, you'll understand why you labeled the bag first. It's hard to write on a bag. Well, first of all, it's round now, and it's hard to write on that. But second, it may be wet. And so record keeping, date, and beach location are a minimum thing to record. If you have some device that gives you latitude and longitude, record that. This is a screenshot uh, of my iPhone. If you open up the compass, it will tell you the latitude and longitude of your location. And there are GPS apps that will do that as well. If you use Google Earth back at home, you'll also be able to find the exact point where you took the sample and get the latitude and longitude. And optional, take a photo of the site. If you're on an expedition where you're collecting sand and you collect dozens a day, as I did on one particular trip, check your notes at the end of the day. It's very easy to get home with 40 bags of sand and um, realize that you forgot to label that one bag of sand. And it's like, oh, it was so obvious when I was there collecting it, which one it was, but you forget. So uh, record keeping is very important. And at home, you want to rinse. I like to remind people that if you collect sand at the coast, you're collecting with water, and that water is seawater. When it dries out, salt crystals will form and they may glue grains together. So you want to wash it out. Sieving it is optional. I know some collectors that have a 2 millimeter sieve and they insist on collecting things that are only less than 2 millimeters. Remove any unwanted material like this sand hopper that I found in sand that I brought home one time. You have them on the East Coast. They're all over on the beaches of the world everywhere. Um, and and then dry the sand and then you can bag it. As soon as you can, assign a catalog number and then store them. As with my history as a professional curator, I like to highlight the difference between an accumulation and a collection. Uh, on the left is an accumulation of spice jars and bottles and all kinds of different containers. That was a collection that was donated to the ISCS, and there are actually 2 layers to each of those boxes, so lots of samples, and then a well-labeled uh, uniform collection on the right. So this shows part of that collection that I uh, took in 21 samples from Hawaii in every imaginable type of container. This is how I store my collection in these 4 mil plastic bags, labeled and all the same. So those are the same samples, just different sample containers, and then they're stored in plastic boxes. Don't expect you to read this. The point of this slide is that I plot things on Google Earth so I can see where my samples are from. And then I also record all that information, including latitude and longitude, what the major components of the sand are, and as much information about the location as possible. And then there are these people who are a bit obsessive about collecting and have tens of thousands of samples in their collection. Um, the guy on the left in that center photo, that is his collection, part of his collection on the right, and he likes to brag that that's the first 1,500 of his samples that he had. He has that display in his living room, apparently. So anyway, this can get out of hand rapidly, especially if you're one of those obsessive people. So container, there are no rules or regulations here about how much you keep or what you put it in. The main thing is whatever suits your needs and your space. Um, some people like to display them. They make nice shelves and to store them on. They have them in racks like that on the left, plastic bottles, all kinds of things, coin holders, and you've seen my plastic bags that I store them in. How much to keep is, again, entirely up to you. Some people only keep a couple of milliliters, uh, and this depends on your preference for container. There's one guy out there that's collecting, and he collects 400 or 800 milliliters of sand. He has two different jars that he has in his collection, so that's a lot of sand. Um, but generally, 1 to 2 tablespoons is enough. And that came from the fact that sand collectors started when film was still a thing, and excuse me, and film canisters were readily available, and they hold 30 milliliters, which is about 2 tablespoons. Okay, so that's what I keep. And I when people go somewhere cool, I tell them to bring me a sand sample. I've now have to remind them that I own a microscope. I don't need a gallon bag of sand from somewhere, so don't do that to me. Just one small bag will do. Growing your collection, there are a couple of ways. You can collect it yourself. You can trade with others. Of course, you need a community to be able to meet up with other people. The way to do that is to join the International Sand Collectors Society. There are also a lot of social media groups out there, ISCS. There's a German group, Samseller, um, Sand Collectors United. And so on the right is a photograph of an ISCS meetup where there was trading going on. I have another picture of that room coming up in just a minute. And the last thing is what to collect. And collectors generally, I've seen this with, with mineral collections, with rock collections, with fossil collections, all kinds of different things that people collect. They collect everything. They want one sand from every beach on the planet, uh, which, a couple of people, I showed pictures of them earlier. They're trying to do that and coming pretty close. You may collect biogenic sands, fossil sands, garnet sands, green sands, specific place. You may want one sand from every state in the United States, for instance, one sand from every country, and on and on. So here is one sub collection, sands from movie film locations. So you have, for instance, the place where MASH, the film TV series MASH was filmed in California. The On Oahu, there's the famous From Here to Eternity Beach, which is really close to Honolulu, as it turns out. Uh, Places where parts of Star Wars was filmed, and on and on. And then a sand like this, it looks like any other sand anywhere, but it doesn't have any meaning unless you know where the sand came from. And this sand, you'll see little black specks in it. They're metal fragments. And when I tell you where this beach is, where the sand with this beach sand was collected, you'll understand the significance of this sand. That sand, as well as this sand, were from Omaha Beach in Normandy, France. And the metal fragments in there are bits of shrapnel, bullets, and all kinds of metal from that awful battle 85 years ago. So 81 years ago. And then I'll end with one last story. And I My number has been posted places. People can find my phone number and give me calls and tell me that they have something they want me to identify. So one day I get a message from a woman, left a detailed message, said that she needed something identified, that she was finding gold in her toilet. And so um, I called her back. I'm a scientist. I'm very curious. And this was when I was living in Georgia. And so I talked to the woman and I said, "So where do you live?" And she told me what city she was in. And I said, "Okay, well, you're in line with the gold belt. So tell me about your water supply." And so she was on well water. And she was finding what she thought was gold in the tank of the toilet. So uh, I'm thinking, okay, so she's got well water. She's pulling up sediment. So the screen that filters the water is not doing its job. So she's getting sediment in there. That's a different issue, but she is getting sand and it's being concentrated every time the toilet flushes. So I said, take some of that sand, dry it, and put it in a baggie, and just send me a little bit of it, and I'll take a look at it. So a few days later, I get an envelope in the mail. I open it up, I look at it, immediately recognize what it is. And this is the gold looking flakes here. They're really bronzy color to me. Um, were weathered mica flakes, and they're reflective. And so, yeah, I could see how, to the untrained eye, yes, that may initially look like gold, but they're very light, flaky, soft, and so on. So I called the woman back and I didn't get an answer. I left a detailed message explaining what I had found and didn't hear from her for a long time after that. And I thought, well, that's the end of that, until the day I got a card in the mail from her. And she said she thanked me profusely for not thinking she was crazy, for taking her seriously, and for investigating it, and appreciated my answer. And then the last line of the card was, well, there go my dreams of a potty of gold. So, okay, again with the books and resources. Uh, two books that I like to recommend in the middle and the right. Sand by Michael Wayland is a very long, very thorough book describing sand. If you want lots of beautiful pictures, The Secrets of Sand, in that book, you'll see the famous star sand from Okinawa there on the cover. That's a great book on sand, and there are many others. If you join the International Sand Collectors Society, you'll get the newsletter, which comes out a couple of times a year, and it is, of course, called the Sandpaper. And we have conferences. This in 2022, we had a Sand Collectors Conference, ISCS conference called Sandfest in Coos Bay, Oregon. And you'll see the group. We had people from a lot of people from Europe came in. That's the president, Lori Carter, on the right. She's actually in the meeting today. And then on the bottom, you'll see the room where we did all the sand trading. All of that sand was giveaway trade sand. So it was absolutely phenomenal event. Um, New thing, as of this week, the ISCS has a new website, and we had a presentation by one of the authors of the book, The Secrets of Sand. Kate Clover gave a great presentation on sands from Galapagos and Iceland and their similarities and differences of these two locations, and it was a fantastic talk. It's been recorded, or it was recorded, and it's now online, and you can go and watch that presentation on our site. You don't even have to be a member. It's right out there in the open, in the wild for you to see. And the last thing I want to say about the ISCS is that we are having Sandfest on the East Coast in Sterling, New York. And that will be September 25th through the 28th of this year. And so go to our newly launched website, a lot of great information and more coming. And I encourage you to join the group and connect with others and learn about the hobby if sand collecting is your thing. So that concludes my talk, and I'll be happy to answer any questions if there are any.
That was great, Julian. Thank you so much. If you can unshare, we'll come back and open it up for Q&A.
Okay.
Thank you so much. All right, so you can put your question in the chat box, or if you raise your hand, I will call on you to ask a question to Julian. There was a question back here. Sarah asked, what are the softest sands?
You're asking a geologist what the softest sand, I'm going to go by what minerals are in it. But that also came up in a different context. If you're walking on sand, dune sand, and I would imagine that white sands, I've never been there myself, but white sands, New Mexico, that sand would probably be very soft to walk on. And that's because the grains are small and they're well rounded, and so they slip and slide, and that would be, in my opinion, the softest sand.
Okay.
My
We have a
guess.
question about Jackie. It's how hard is it? People are having problems getting sand through customs or the airports. What do
Right.
you do?
Yeah, that's tough. And there are countries, there are a few countries that will not allow you to collect sand. Um, I've heard that Italy is one of those countries, which is a shame because there's such beautiful sands there. And India, and probably because India is one of those countries that's having trouble with the sand mafias and things like that. So, I mean, you're confusing collecting sand with stealing tons of sand in that case. But yeah, we have heard stories of people going through customs and having their sand inspected. They question the traveler, and in some cases confiscated. I know somebody that went on a trip to Australia and collected all these sands, and every bit of their sand was confiscated, so they brought none of it back. And
Ugh.
that's a thing that's going on, and I don't know what to do about it. Hawaii is also frowns on collecting of sand here within the states. In Oregon, we have the opposite. The beaches belong to the people. There was a beach bill was passed in the 1960s, giving the beaches to the citizens of Oregon, and you can collect sand. And as you know, as long as you don't collect more than 5 gallons, 5 gallons a year. Uh, so, um, but yeah, it's unfortunate, and I don't know. Maybe I can't make any promises, but it seems like this might be something that the ISCS might want to, I don't know, get into. And once we can prove that we're legitimate people interested in studying sand and learning about sand, it's an educational activity. Then perhaps we can thaw some of those relationships. But uh, that's just me. That's my personal opinion.
Adrian asks, how long have you been collecting sand?
That's hard to answer because I had a very diffuse beginning. I think I put it at 2012, and uh, I had sort of informally been picking up sand. And it's a shame that as a geologist, all the cool places I went early in my career, I didn't pick up sands at those places. Um, but in 2012, when I was still living in Georgia, the Georgia Mineral Society started a sand section. And our first meeting was January of 2012. And um, a bunch of us, about a dozen of us, got together and swapped sands. And that's when I first started really accumulating sands intentionally. And so after that, it just mushroomed. And here we are today with boxes and boxes and boxes of sand everywhere. So,
Jackie's interested in learning the techniques for epoxying, slicing, grinding samples for microscopic study.
okay. Um, there was actually an article in the Mineralogical Society of America, their journal, American Mineralogist, on doing that for somebody was using tubes, and they were pouring grains and epoxy in tubes and then putting them together and then slicing them and getting wafers that they could glue to microscope slides, and it was pretty cool. So if I can give you my email and feel free to reach out to me, and I can send you that article. And also, I've written up the method that I have a professional lab that makes thin sections for me, and I can share that as well. So my email is juliangrocks@gmail.com. Julian G Rocks, JULIANG Rocks at Gmail.
All right. We have Jocelyn asked, what do you call sand when it's made up of a conglomerate of different things? Fossils, glass, metal minerals, etc. Do you just label it as what the majority of it's made out of? Thinking they went to Calvert Cliffs, and so there was a whole bunch of different things.
Yeah. Um, yeah, absolutely. You label it by the dominant component. So whatever is most abundant. And uh, you know, um, I tried to come up with some mathematical thing where it's like, okay, well, if it's greater than 50% or something, then I realized you can have 40% and then a 30 and a 20 and a 10. So whatever's dominant. And it's just an eyeball approximation of what's the dominant component.
I have a question. Is when you said that you were doing a survey of a beach, how different is the sand from one side of a beach to the other side of the beach, or from the bottom of the beach to the top of the beach? And if you're taking samples as a representative of a specific area, are there guidelines on
Yeah, and if you're doing, there have been a number of studies that people have done, master's theses and things like that, where people have sampled beaches, and uh, I I think that they'll take the top a thin layer off, a centimeter or two off, because that's generally wind blown and a little bit mixed, and then go down an inch or two and just take sand, and they generally get it from the swash zone. So, which is in between low tide and high tide. So somewhere in that area, um, best to go to the beach at low tide, um, and collect those sands. And as far as variation, it depends on the beach. And uh, I've been there are beaches that I can point to in here in Oregon, and there are probably other places where I can collect four different types of sands. I've collected one sand rich in biogenic components, a garnet sand, and then a tan sand with quartz and feldspar, and then a magnetite sand, all from the same beach. And 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 then also, dig down. If you dig down, you'll find layers. The those heavy mineral sands, those magnetite-rich sands, sometimes concentrate in black layers. And if you look at dunes, if you see ripple marks, you'll see a um, dark sand in the trough and light sand on the crest of the ripple marks, from wind sorting. Yeah, it makes it very interesting. You go to the coast of Georgia through Florida and around, um, and all the beaches are pretty homogeneous. They're just white sand. They're sugar sand. It's mostly quartz, and then you get down to Florida, you get into warmer warmer water, and you see more biogenic. You see more shells and things on those beaches. Yeah. It's part of what makes it fascinating. So I see Alan's got his hand up. So.
that? Yep, go
So
ahead, Alan.
I have my standard question, one, and then I've got sort of, I think, maybe a peculiar question. But the standard question is just how you got interested in mineralogy, geology. I can really remember that I had a rock, just like 12 rocks in a box I must have gotten at a museum gift shop. And, and I must have been like 6 years old, but I just remember being so, taken by it and fascinated by it. So that's just that piece of your background. And then is there anything you can share on like sand in hourglasses? Is there any sort of rhyme or reason system, whatever, to how that's done?
Okay. First question. I grew up um, in a suburb of Atlanta, and it was newly developed. There was construction nearby, and I was a latchkey kid. So every night, every day I'd come home from school and I'd just wander through the woods and explore. And I was picking up everything, just leaves, twigs, bugs, everything. And uh, and then, like you, I was 12 years old when it happened, and, of the year that I turned 12. And uh, I had this box of rocks, and I had a book that had names of rocks. And I'm like, all of these rocks have names. I need to know what they're called. And I started studying them. And uh, looking, no, I don't have sample number one is usually within arm's reach, but I found a tourmaline crystal in 2 blocks from my house. It's a beautiful mineral. And, as a 12-year-old kid, I had no idea what I had found. It was really cool. And that just set me off. And I was on fire after that. I just love minerals and I've been passionate about it ever since. And then, when I discovered, as my eyesight started failing and I needed microscopes and hand lenses to look at things close up, oh, look at all these sand grains, I can see them now in the microscope, and fell in love with that aspect of the hobby. So, hourglasses. Um, at the Sandfest in 2022, we had a German sand collector gave an entire talk on hourglasses. And it, yeah, you think about it, it's like, how did they do that? First of all, many of the sands are artificial and they're created. They're all identically sized and shaped so that they will fall through the narrow part of the hourglass. And then the older hourglasses were actually two bottles. And then they would put them together and they would have something that would join the two bottles together. But then glass blowers got more clever and they were able to blow glass and seal it up. It is fascinating, but it's not a subject I've really gone into in any depth. But that's about I'm at the end of what I know about hourglasses.
No, thanks. And it was just enough that someone presented on that. It was like, yeah, that it
Everybody,
gets
there
to
are
that level.
people out there will study everything in incredible detail. It's amazing.
Jackie asked she finds sand with windblown surface of fine black grains. What could that mineral be?
Fine black grains, wind blown. Probably magnetite is the most likely thing. And uh, in the deserts, there's different chemistry, different environment altogether. If it's in a desert, then you also get desert varnish. And I don't know of any cases where um, uh, sand grains probably get desert varnish as well. Um, And that's generally a manganese oxide on them, but the black sand grains, if it's black through and through, and of course it's magnetite, it's strongly attracted to a magnet, so you can wave a magnet over it and check that.
Thank you. That's a great idea.
Thanks.
All right. Do we have any other questions? Or has the what is it? The sands of time gone through our hourglass, and are we're ready to call it a night?
I can hear the music now.
Yeah.
Can I ask one more question?
Go ahead.
What makes a good sand for sandcastle building?
Ah,
Annual.
a damp sand. There's a perfect moisture content. If it's too dry, it will just roll out into a cone. And if it's too wet, the same thing, it'll just spread out. But if you get it damp enough to just that surface tension of the water will hold the grains together just enough to hold them up. And then, of course, once it dries out, it will fall apart. So just experiment with moisture.
I have one
Yeah.
question.
And they had, when I was looking at some of the videos, they had people that were all constantly spraying the sand as they were building it
Right.
to keep that.
Yep, keep it from drying out. Yep.
Hmm.
Hopefully they weren't spraying it with glue. That's cheating.
I have one question.
Yeah.
I studied soil science, and that was the area that I worked in for many years. And I'm still blown away by the great deserts of the earth. I still don't understand and have never had a satisfactory explanation as to how so much sand that is so uniform in structure can be in one place. What on earth created the great sands in the great deserts of the world,
Yeah.
in your
Ex
opinion?
yeah. Excellent question. I don't know the full answer. Um, it has to do with the latitude where they're found, is the first part, which is the climate is so dry that it can't support much plant life. And then, so there's nothing to stop wind, and you get wind blowing it around. And uh, that, as I pointed out in my talk, is a good sorting agent. And it also, things are being tumbled by the wind as they're blown around. So you get the same grain size. But as far as the volume of sand, it's enormous. I mean, um, you know, we were talking about the Great Sand Dunes in Colorado, and even that, if you look at it on a globe, it's just a speck. But if you're standing on the Great Sand Dunes, it's huge. They're enormous. And even there, how did you get so much sand? I don't have an answer. It's one of those amazing places on the planet.
Okay, well, I've asked that to several geologists, and you're not, and you are among all of them with the same answer.
I'm one
It
of them.
still amazes me. Yeah,
Yeah.
yeah, same answer,
Yeah,
but thank you. Thank you for trying.
we can be amazed. That's why we keep doing this.
Yeah, it's so amazing. Yeah.
And I just have a shared, childhood, whatever sand, maybe it's a common shared experience of that, just standing on the edge of the water at the ocean and just sort of having the sand getting worn away and your feet are
Oh, yeah.
sinking down. I mean, it's a sensory memory.
There's a lot of physics going on in sand at the beach. It's really
Mm,
pretty cool.
yeah.
Well, Julian, thank you so much for sharing your passion and knowledge of sand with us tonight for Must Learn Thursday. And thank you all for joining us. And hopefully we'll see you next week when we learn about the quails, protecting quails and pheasants in Maryland. But until then, stay well, stay curious, stay outside, and let's go collect some sand. Good night, everybody.
And
Night.
everybody, thank you so much. That was wonderful, really wonderful.
All right. Thanks for having me. Appreciate it.
Thanks, Julian. That was great. Thank you so much. Take care.